What if Antarctica completely melted? Asterisk. When the white continent vanished, at the southern end of our planet lies a continent hidden beneath ice. Antarctica is larger than Europe. In some places, its frozen surface rises thousands of meters above the land below. It contains mountains, valleys, lakes, and ancient landscapes that have remained buried for millions of years. But most importantly, Antarctica holds the majority of Earth's freshwater ice. To us, it appears distant, silent, almost disconnected from human civilization. Yet the future of every coastal city on Earth is tied to what happens there. Now imagine that the planet begins warming far faster than scientists ever expected. Ocean temperatures rise. Warm currents move beneath Antarctica's floating ice shelves. The great walls of ice protecting the continent begin cracking. And within only a few decades, the entire Antarctic ice sheet melts. At first, the changes might appear small. Satellites would detect dark blue pools forming across the white surface. Rivers of meltwater would cut through the ice. Sections of floating ice shelf would fracture and drift into the ocean. Tourists and researchers would witness enormous icebergs breaking away with sounds like thunder. The images would spread around the world. But many people would continue living normally. Antarctica is thousands of kilometers away from most major cities. Its collapse would feel like a distant story. Until the oceans began rising. The first major danger would not come from ice already floating in the sea. Floating ice shelves displace water, so their melting alone would not dramatically raise global sea level. The true threat would come from the vast ice resting on land. As that ice melted and flowed into the ocean, it would add enormous amounts of new water. If all Antarctic land ice disappeared, the average global sea level could rise by roughly 58 meters. That is almost the height of a 20-story building. But the rise would not happen all at once. Year after year, the sea would move farther inland. At first, the difference might be measured in centimeters. Then, meters. Beaches would narrow. Storm tides would travel deeper into coastal neighborhoods. Roads that once flooded, once a decade, might begin flooding every year. Then every month. Eventually, they would remain underwater permanently. Governments would build seawalls. Pumps would operate day and night. Cities would raise roads and reinforce harbors. Wealthy districts might surround themselves with barriers. But every wall would have a limit. And the ocean would keep rising. 1 meter of sea level rise would already threaten millions of people. Low-lying islands would begin losing fresh water as salt water entered underground supplies. Coastal farmland would become too salty to grow crops. Wetlands would disappear beneath deeper water. Storm surges would reach communities that had once been considered safe. At 5 meters, the map of the world would begin changing dramatically. Large parts of southern Florida would vanish. Many neighborhoods around Miami would be abandoned. Sections of Bangladesh would disappear beneath the Bay of Bengal. The Nile Delta would retreat. Low-lying parts of the Netherlands would depend completely on larger and more expensive defenses. Coastal cities across China, Southeast Asia, Africa, Europe, and the Americas would face permanent evacuation. But Antarctica would still be melting. At 10 meters, some of the world's most famous cities would become impossible to protect completely. New York would lose large areas around its harbor. London's flood barriers would no longer be enough. Shanghai would retreat inland. Jakarta, already vulnerable to flooding and land subsidence, could disappear beneath the sea. Bangkok's low plains would become part of the Gulf of Thailand. Ho Chi Minh City and large areas of the Mekong Delta would face repeated flooding before becoming permanently submerged. Millions of people would move away from coastlines, then tens of millions, then hundreds of millions. Human civilization has always gathered beside water. Rivers and oceans provide food, transportation, trade, fertile soil, and access to the wider world. Many of our largest cities were built close to sea level because the sea connected them to global commerce. Ports became centers of wealth. Coastal plains became farmland. Entire nations developed around deltas and islands. A 58-meter rise would not simply flood a few beaches. It would erase much of the geography on which modern civilization was built. As the water rose beyond 20 meters, large sections of present-day coastlines would disappear. Florida would become a group of smaller islands. The United States Gulf Coast would retreat far inland. The Amazon River would widen near its mouth. The Mediterranean would invade low coastal plains. The Persian Gulf would expand. Many island nations would cease to exist as physical territories. Their governments might survive in exile. Their people would survive in other countries. But their homelands would lie beneath the ocean. At 40 meters, the scale of displacement would become almost impossible to manage. Ports would be rebuilt farther inland, only to be abandoned again as the water continued rising. Railways, highways, airports, power plants, refineries, factories, and warehouses would be swallowed. Historic centers that had survived wars, earthquakes, and centuries of change would disappear. Venice would be far beneath the surface. Amsterdam would be gone. Large sections of Copenhagen, Hamburg, Alexandria, Lagos, Mumbai, Kolkata, Guangzhou, and countless other cities would vanish. The coast would move tens or even hundreds of kilometers inland in some regions. People would watch the sea approach places that had never known ocean waves. Forests would die as saltwater reached their roots. Freshwater lakes near the coast would become brackish. Rivers would slow as the sea pushed farther upstream. Old towns would be evacuated. Their residents might mark the final day with ceremonies, before leaving homes their families had occupied for generations. Then the water would arrive. In this scenario, humanity would have several decades to respond. That sounds like a long time, but rebuilding much of civilization within a single human lifetime would be an almost impossible task. New inland cities would need to be constructed. Housing would be required for billions of displaced people. New roads, hospitals, power systems, farms, schools, and water networks would need to appear faster than entire countries had ever built them before. Land would become one of the most valuable resources on Earth. High ground that had once been remote or inexpensive would suddenly become desirable. Governments might prevent people from moving freely. Borders would close. Wealthy nations could try to control migration. Poorer countries would struggle to relocate entire populations with limited resources. Conflict would grow between communities already living inland and those arriving from flooded regions. People would not only be competing for land, they would be competing for water, food, jobs, housing, and political power. The world's economy would be placed under enormous pressure. Coastal property worth trillions of dollars would become worthless. Banks holding mortgages on submerged homes could collapse. Insurance companies would be unable to pay for repeated disasters. Global shipping would be interrupted as ports disappeared. New ports would require years to construct. Factories built around existing supply routes would be abandoned. The movement of food, fuel, and medicine would become less reliable. The rising sea would also threaten agriculture. Some of the world's most productive farmland lies in river deltas and coastal plains. These regions are flat, fertile, and densely populated. As seawater moved inland, salt would poison the soil. Rice fields in major Asian deltas would decline. Vegetable farms near coastlines would disappear. Freshwater irrigation systems would be contaminated. At the same time, displaced people would require more food than ever. Humanity could attempt to build vertical farms, expand agriculture into northern regions, and grow salt-resistant crops. But those solutions would require energy, technology, and political stability, all of which would be under pressure. The oceans would not rise evenly everywhere. Antarctica's enormous ice mass currently pulls ocean water toward it through gravity. As the ice vanished, that gravitational attraction would weaken. Sea level near Antarctica could rise less than expected or even temporarily fall in some places. Farther away, especially in parts of the northern hemisphere, the rise could exceed the global average. The redistribution of water would also slightly change Earth's rotation and gravitational field. The planet would remain stable, it would not tip over. But instruments would detect that mass had shifted from the southern continent into the global oceans. The shape of Earth itself would be changing. Antarctica would also begin rising. The weight of its ice has pushed the land downward for millions of years. As that weight disappeared, the crust beneath the continent would slowly rebound upward. Mountains and valleys would emerge from beneath the melting ice. New islands would appear. Ancient river channels would be exposed. For the first time in human history, we would see the true surface of Antarctica. But before scientists could explore it, the collapsing ice would create one final danger. Huge lakes of meltwater would form on and beneath the remaining ice sheet. Natural ice dams could fail. Enormous floods would race toward the coast. Icebergs larger than cities would enter shipping routes. The Southern Ocean would fill with fresh water, sediment, and drifting debris. The last pieces of the white continent would disappear into the sea. And when the melting finally ended, the ocean would stand nearly 60 meters higher. Humanity would look at maps drawn only a few decades earlier and see a lost world. The streets where billions once lived would lie beneath the waves. But the flooding of the coast would be only the beginning. Because removing Antarctica's ice would not merely change the land, it could change the machinery controlling the entire planet's climate. The new world after the ice, when the last Antarctic ice disappears, Earth becomes a different planet. The familiar white continent at the South Pole is gone. In its place is a dark landscape of mountains, exposed rock, deep valleys, and newly formed seas. Some regions remain connected as one large continent. Others become islands separated by water-filled basins that had once been buried beneath kilometers of ice. From space, Antarctica no longer appears as a brilliant white cap. It is brown, black, green in a few warming coastal regions, and surrounded by a rapidly changing ocean. But the most important transformation may be invisible. The global ocean is constantly moving. Warm water travels from the tropics toward colder regions. Cold, dense water sinks and returns through the deep sea. Together, these currents move heat, nutrients, oxygen, and carbon around the planet. Antarctica plays a major role in this system. Cold, salty water forms near its coasts and sinks into the deep ocean, helping drive circulation that connects almost every sea on Earth. The sudden arrival of enormous quantities of freshwater would disturb this process. Freshwater is less dense than saltwater. Instead of sinking easily, it would remain near the surface. The formation of deep Antarctic water could weaken dramatically. Ocean circulation patterns might slow, shift, or reorganize. The effects would spread far beyond the southern hemisphere. Some regions could become warmer. Others might experience unexpected cooling. Rainfall patterns could move. Monsoons could weaken or intensify. Nutrients normally carried upward from the deep ocean might reach different locations. Marine ecosystems that had depended on stable currents for thousands of years would face rapid change. The ocean would also absorb more heat. Without bright ice reflecting sunlight back into space, Antarctica's darker land and surrounding water would absorb far more solar energy. This is known as the albedo effect. White ice reflects much of the sunlight that reaches it. Dark ocean water absorbs it. As the ice disappeared, the region would warm even faster. The melting would create conditions encouraging more warming. By the time all Antarctic ice was gone, Earth's climate would already have entered an extreme new state. The frozen ground beneath parts of Antarctica could release gases and organic material that had remained trapped for very long periods. Newly exposed soils would react with the atmosphere. Microorganisms would enter landscapes untouched by sunlight for millions of years. Scientists might discover ancient biological material. They could find microbes adapted to extreme cold and darkness. Some organisms might provide new knowledge about life on Earth, or the possibility of life on other planets. But exploration would occur during one of the greatest humanitarian crises in history. Billions of people would be living farther inland. Former coastal nations would have new borders. Some countries would lose most of their territory. Others would gain new coastlines. Cities once located hundreds of kilometers from the sea could become major ports. New York, London, Mumbai, Shanghai, and many other modern coastal centers might survive only as names, historical records, and underwater ruins. Divers and submarines could travel through their streets. Fish would swim through apartment buildings. Coral might grow on monuments. Ships could pass above old highways. The drowned cities would become the largest archaeological sites humanity had ever created. In some places, governments might preserve them as memorials. In others, valuable metals and materials would be recovered from beneath the water. The old world would become a resource for the new one. New capitals would rise on higher ground. Governments might move administrative centers into mountains or continental interiors. Major populations could shift toward regions that had once been colder. Northern Canada, Scandinavia, Siberia, Alaska, and elevated areas of Central Asia might become more important. But warmer temperatures would not automatically make all northern land fertile. Soil quality, sunlight, water supply, and infrastructure would still limit farming. Some regions might become suitable for crops. Others could turn into wetlands, forests, or unstable ground as frozen soil thawed. People escaping flooded coasts might arrive only to face fires, droughts, or unfamiliar diseases. The collapse of Antarctica would not create one simple global climate. It would create instability. Some regions could receive too much rain, others too little. Powerful storms might travel along new paths. Warmer oceans would provide more energy for tropical cyclones. Although coastlines had moved inland, the new coastal cities could still be struck by severe storms. Humanity might repeatedly rebuild farther from the sea. Eventually, coastal construction would be treated with extreme caution. Major cities could be designed at elevated locations. Buildings might stand on high foundations. Critical infrastructure would be placed underground or far inland. Floating neighborhoods could become common. Instead of trying to hold the ocean back, some communities might learn to move with it. Human settlement would become more adaptable. But adaptation would not be equal. Wealthy regions could construct new cities, desalination plants, protected farms, and advanced transportation networks. Poorer populations might live in enormous temporary settlements. Generations could grow up in migration camps. Citizenship would become complicated for people whose countries no longer physically existed. Could an island nation remain a nation after all its islands were submerged? Would its former citizens still own the waters above their lost homeland? Who would control the minerals, fish, and shipping routes in those regions? The rising sea would create new political conflicts. Maritime borders were originally drawn around coastlines that no longer existed. Countries could argue over where old boundaries should remain. Newly flooded regions might contain oil, gas, minerals, and valuable fishing grounds. Military ships could guard waters that had once been farmland. New alliances would form between displaced nations. Some groups might demand territory from countries with more surviving land. Others might attempt to purchase or lease regions for permanent resettlement. The greatest migration in human history could also become the greatest test of human cooperation. The natural world would experience equally dramatic disruption. Emperor penguins depend on Antarctic sea ice for breeding. Without it, their traditional habitat would vanish. Seals that rest and raise young on ice would decline. Krill populations could be transformed by warmer water and reduced ice. These tiny animals are a foundation of the Southern Ocean food web. Fish, penguins, seals, and whales all depend on them. If krill collapsed, the effects would move through the entire ecosystem. Some species would migrate farther south, only to discover that there was no colder region left. Others might adapt to open water. New fish species would enter the warming Southern Ocean. Whales could change migration routes. Plants, insects, birds, and microorganisms would begin colonizing the newly exposed Antarctic land. At first, only mosses, lichens, algae, and hardy grasses might survive. Over centuries, larger ecosystems could develop. Seeds carried by birds and wind would reach the continent. Humans might introduce crops and animals intentionally. New towns could appear along Antarctica's warmer coasts. The continent, once considered almost uninhabitable, could become the world's newest frontier. Nations would compete to control its resources. The land beneath the ice contains rock, possible mineral deposits, and ancient geological records. With the ice gone, mining would become easier. Roads and ports might be built. New settlements could grow around research stations. But the exposed land would remain unstable. The crust would continue rising as it recovered from the lost weight of the ice. Earthquakes could occur as pressure changed. Volcanic regions beneath West Antarctica might become easier to study. Meltwater lakes would occupy deep basins. Some of these basins lie below present sea level and could become inland seas connected to the surrounding ocean. Antarctica would not simply resemble another green continent. It would be a strange landscape shaped by millions of years beneath ice. Across the rest of the world, humanity would search for ways to prevent another planetary transformation. Fossil fuel use might end almost completely. Carbon removal systems could operate on a vast scale. Forests would be protected and expanded. New technologies might attempt to reflect sunlight or cool the atmosphere. But once the Antarctic ice had completely disappeared, rebuilding it would be extraordinarily difficult. Ice sheets are not simple piles of frozen water. They form over thousands of years as snow accumulates, compresses, and slowly spreads. Even if temperatures fell again, restoring the lost ice could take many millennia. The elevated white surface that once helped keep Antarctica cold would be gone. The darker land would absorb more warmth. Humanity might be able to stop further warming, but the old coastlines would not return within any meaningful human timescale. Sea walls could not bring back the drowned cities. Maps could not restore the islands. The world would have to accept its new shape. Children born generations later would study the 21st century coastline in history books. They would see maps of Florida, Bangladesh, the Netherlands, the Mekong Delta, and thousands of former islands. They might struggle to imagine that millions of people once lived beneath the waters outside their new cities. Museums would display objects recovered from submerged homes. Street signs, cars, phones, furniture, photographs damaged by saltwater. Families would preserve stories about towns that no longer existed. Some would return by boat to the coordinates of ancestral homes. They would stop above the water, knowing that far below lay a school, a road, or a house where their grandparents once lived. Over time, humanity would rebuild. New trade routes would form. New ports would open. Agriculture would move. Cities would rise on higher ground. The human species would survive. But the cost would be almost beyond calculation. Antarctica appears empty to us because few people live there. There are no large cities, no permanent indigenous population, no highways connecting crowded neighborhoods. But its ice protects cities everywhere else. It stores water that would otherwise be part of the ocean. It reflects sunlight. It influences currents. It preserves a climate history reaching back hundreds of thousands of years. The frozen continent is not separate from civilization. It is one of the systems making civilization possible. Every block of ice lost from Antarctica may seem distant. But the water does not remain in the south. It joins one global ocean. An ocean touching every continent. An ocean surrounding every island. An ocean waiting beside many of the world's largest cities. So imagine standing at the edge of a coastal street. The buildings are empty. The windows are dark. Everyone has already moved inland. Far in the distance the water is approaching. Not as a single giant wave. Not with an explosion. But slowly. Relentlessly. Year after year. Until the street disappears. Then the buildings. Then the entire city. Antarctica does not need to come to us. All it has to do is melt.